Today we are going to see about tree data structures, which is the most important topic which you have to go through while studying data structures. So in tree data structure, first we'll be seeing what is a tree ADT, how it aligns with the real world environment, then further traversals, then we'll be seeing about different trees like binary tree ADT, expression tree, binary search tree, AVL tree, and further B and B plus tree. So let's move on to the video. In previous video we saw about the fundamentals of tree, how a tree looks, what is a root, what is a parent, what is a child, etc. So these are the basic terminologies you have to see. So consider this diagram. So with this diagram I'm going to explain what are the key terminologies once again. So root, the topmost node of the tree is called root node. So this is my topmost node of my tree, so this is called my root node. So then parent node, a node that has child nodes. So the nodes which have child nodes according to this diagram is 3, 5, 6. So these are all called the parent nodes. So child nodes, node that descendant from a parent node. So child nodes are 2, 3, 5, 4, 6, 7 are all child nodes. What do you mean by sibling nodes? Is nodes having the same parent. So here the siblings are 2 and 3 are siblings which is going to share a common parent 1. So 5 and 4 are siblings which is going to share a common parent 3. So these two are called siblings. So what do you mean by leaf is, which is also called as external node, a node with no children. So this 2, 4 will never have a children. So these two are called leaf nodes. So then what do you mean by internal nodes? Are a node that has at least one child, or else how you can say is the nodes except leaf node, the other nodes are called internal node. So ancestors, any node on the path from the root to a particular node. So for this node 4, you will be having ancestor, that is a previous node. So those are called ancestor. Descendant node, which means successor of this node. For 5, 6 is the descendant node or successor node. What do you mean the degree of a node is? Number of children the node is going to have is the degree of that node. For example, if you consider 1, the degree of 1 is 2 because it has 2 children. So the degree of a tree is a degree of a node 1 is 2. So what is the degree of a tree is? Maximum degree of any node in the tree. For example, since it is a binary tree, it is having 2 children. Suppose if I am considering a normal tree or 3-way tree, what is the maximum degree of a node in a tree is that node's degree will be taken by the degree of a tree also. So maximum degree of any node in the tree is called the degree of that particular tree. So what do you mean by level is the distance or edges from the root to that particular node. For example, if I consider 6, the edges, number of edges from root node to this node. For example, always you have to start from the root node. I have to reach 6. So 1 to 3, 1 edge, 3 to 5, 1 edge, and 3 to 6, again 1 edge. So totally 3 edges. So level is the distance from the root to that node. So what do you mean by height of the node is length of the longest path from the node to the leaf. So the bottommost node is 7. So from root, what is the height? How many number of edges we have to count to reach this 7? Node 7 is the height of that node, so height of that tree. So for example, 1 to 3 1 edge, 3 to 5 1 edge, and 5 to 6 1 edge, and 6 to 7 is 1 edge, totally 4 edges. So the height of the tree is 4. So subtree, a tree formed by any node and its descendants are called subtree as stated in the previous video. So path, sequence of node connected by edges is called path. So what do you mean by edge? The connection between two nodes are called edges. Null tree or empty tree, which means a tree with no nodes are called empty tree. So forest, a collection of disjoint trees are called forest. So these are the basic terminologies you have to go through. So you have to be clear with this basic terminologies to familiarize with the trees, types of trees and their operations. So So this is a small assignment for you all. So your mission is to map your family members to tree roles. Who's the root? Identify the parent relationships, find the siblings, and count the leaf nodes. So this can be your assignment for your after seeing this video, please comment me on this assignment. So types of trees. So in this, according to our course, we'll be having 4 types of trees which we are going to see in this unit: binary tree, binary search tree, avial tree, and then heap. What is binary tree is each node has at most 2 children. So maximum number of children a node can have is only 2. So that's why it is called binary tree. So the binary tree with some advantages, it is stated as binary search tree. What the advantage or constraint is, the parent node will have a left child if it is if the value of the left child is less than the parent node. So for example, if we form a root node and we are reading the next element to fix in the tree, if that element is less than, it goes as the left child. If the value is compared with the root node and if it is greater than the root node value, it goes as the right child. So this is the perfect blending of the binary search tree. So here I'm considering a node, and if I'm reading the next node to insert into the tree, if the node is for first the node is compared with the root node, if it is greater it forms the right child, and if it is lesser it forms the left child. So this is perfect for searching instead of binary tree. So the next tree we are going to use is avial tree. So avial tree is a self-balancing binary search tree that maintains height balance automatically to make your searching very faster, because in a binary search tree, if we insert elements, so there is a chance of being your tree skewed in either left or right. So to balance, so if we search an element in the skewed tree, your searching takes long amount of time. So for searching it takes further amount of time or larger amount of time. To reduce your searching time, you're going for the self-balancing binary search trees, that is avial search tree. So here we are going to perform several rotations to make your tree balanced with the height, so your searching becomes easier and cheap. So this is the major objective we are going for the avial tree. The next one is we are going to see about heap. What heap is, it is also a binary tree used for priority queues and sorting. For example, if we arrive at an emergency situation, how a priority can be given to an element to complete the process. So this is what about heap. So these are all the basic topics we are going to basic topics in trees we are going to see in this